Okay, guys, welcome to our screencast over chemistry basics. So these are like major topics and major areas of content that will basically be present throughout the year, in some chapters more than others, but we're going to cover essentially 4 different things. Some of them are related, and so you'll see that as we go through the different slides. So we've got 6 slides to go through. Our first one, we are going to be taking a look at the different states of matter. Okay, so there are 3 states of matter. There is a 4th one called plasma, but for now, we're going to talk about just solids, liquids, and gases. These are the states of matter that you guys have been given textbook definitions about since you were in 3rd grade. But in chemistry, we like to talk about them in terms of the particle world, because this is chemistry and we deal with tiny atoms and molecules, particles. We want to know what's going on at the particle level. So in a solid, liquid, and gas, the particles have a certain amount of energy, okay? They have a certain amount of energy associated with them. And the state of matter with the lowest kinetic energy is the energy of movement. Those that are barely moving in place, you can't even tell they're moving in place. Solids, we can't tell, but at the particle level, they are ever so slightly moving in place. Now, in the gas state, kinetic energy is very high, so high that gases do not have a set shape or volume. Solids have a definite shape, definite volume. Liquids don't have a definite shape. They take on the shape of their container, but have a definite volume. And this all has to do with energy. So you can see that as we go from a solid to a liquid state, which is called melting, when we go from a liquid to a gas state, which we call vaporization or evaporation, liquid to a gas, what is occurring here is energy is increasing. We are going from a low kinetic energy state to a higher one. And as we go further away from a solid all the way to a gas, we go from lowest kinetic energy state of matter to the highest. Now, in order for this to happen, we have to add energy. Energy has to come in. It has to be absorbed. Now, this actually has a name, and many of you have probably heard it before, but we're going to talk about it. There is a process where energy comes in and causes particles to move faster and have more kinetic energy overall. And this is what is known as endothermic. An endothermic process is when particles absorb energy. Energy comes in, okay? So you can think endo, think in. Energy comes in. So as these particles are melting, going from a solid to a liquid, and then vaporizing a liquid to a gas, the particles are speeding up. They're taking in energy, an endothermic process. So melting and vaporization of particles is known as an endothermic process. Now, let's just do a sample. So let's just talk about H2O. Let's talk about water, okay? Water in a solid state, we call that ice. Water in a liquid state, well, we just call that water. Water in a gas state, we refer to that as water vapor, okay? Now, in each one of these, as we go from left to right, that is, as we absorb energy, we go from a low kinetic energy state to a high kinetic energy state. And this is what is known as endothermic, all right? Energy comes in. Now, we're going to take a look at this same image, but we're going to do so by looking at the opposite or the reverse process, which is where we remove energy, okay? So let's talk about starting with the gas. So let's say right here, once again, this is high kinetic energy, this is low kinetic energy, because then the gas state, they're moving about a lot. They got lots of energy, okay? Now, high kinetic energy. So let's say we take away energy and gas condenses. This is called condensation, all right? These are the different phase changes or different changes in the state of matter. Or let's say that we go from a liquid to a solid. This would be freezing. So this would be, as with our water, this is when water becomes ice. This is when the humidity in the air overnight, condensation, and then the temperatures drop at night, which takes energy away, and the water molecules slow down and become dew on the grass in the morning. So condensation and freezing. Now, these are different than the processes up here of melting and vaporization. And melting and vaporization is when energy comes into the lives of these particles and they speed up. So this was endothermic, if you remember. The opposite of an endothermic process is known as an exothermic process. Now this makes sense because we're removing energy. Energy is exiting. Energy leaves these particles. So in order for these particles to slow down, so you can see these gas particles start to slow down when they become a liquid, and even more so when they become a solid, they have to release their energy, get rid of it. So energy leaves, and these are exothermic processes. So when we think about solids, liquids, and gases, and the energy they have, remember that there is always low kinetic energy towards the solid state, high kinetic energy towards the gas state, and that if you are going from one to the other, if energy is leaving, that is from a gas to a liquid in condensation, or liquid to a solid, that is if energy is being removed and we are going this way, it is exothermic. The particles are slowing down. If energy is coming in, adding energy, and the particles are speeding up, that is known as endothermic. Energy comes in. Now, the next thing we're going to talk about is like at the heart of chemistry, and that is chemical reactions. Like what actually makes a chemical reaction. First of all, when you put sugar in water and you mix it and stir it to make a sugar water solution, that's not a chemical reaction because you still ultimately just have sugar and water. In order for something to be a chemical reaction, you have to have matter that you begin with that creates new matter that you end with. So in this chemical reaction, we have hydrogen peroxide, which is H2O2, that breaks down to become H2O, just water and oxygen gas. These are chemically different, chemically new substances formed. Okay? You begin with an old substance, we're just going to call it old, okay? But this is the original substance that you start with, and you've got new substances. Bonds are broken, new ones are formed, okay? That is what makes something an actual chemical reaction. Now, I do want to point out what the parts of a chemical reaction are called, the things that you begin with, okay? Now, right here, we only have one, but sometimes you've got something else that you're adding to this reactant but in this case, we only have one reactant. So, the one thing we want to discuss is, and I'm trying to get that covered because we're not ready for that yet, but this is what is known as a reactant, okay? So, your reactants is what does the reacting, and then the product or products are what you produce. So this makes sense. You produce products, okay? The reactants are what are doing the reacting, okay? So you've got your reactants that are always on the left of a chemical equation. They're what you begin with. And then the things that are on the right of the chemical reaction, they're what you end up with are your products. Now this right here is your yield arrow, okay? Your yield arrow is kind of your dividing line between this is what you start with and then this is what you form, okay? So the yield arrow just says I started with this and now I formed or created this. Yield is just letting you know that. Now this right here, and it even tells you, now this is always not written here, but I did keep this in this slide for the sake of understanding what a catalyst is. This MnO2, which is manganese oxide, all right, is a catalyst. A catalyst is anything that speeds up a reaction, okay? It allows the reaction rate. Sometimes you need a catalyst in order for a chemical reaction to take place. So this is going to speed up your reaction rate. And a lot of times, this, like I said, is something that will need to be added or present in order for the reaction to even occur. All right, so that is a catalyst. Now, over here, I want you to notice something, and this is going to create a connection with the last slide that we talked about, energy. Notice how energy is actually something that is produced in this chemical reaction. So just earlier we talked about endothermic and exothermic. In chemical reactions, if you produce energy, that means that energy is actually going to be released into the environment. So as this chemically breaks down into water and oxygen gas, energy is released. So in a chemical reaction, if you have energy that is released, it is known as exothermic, okay? So released, remember we said exo exits. So if energy is released and is a product in a chemical reaction, this is an exothermic chemical reaction. And actually, there's going to be heat released to the environment. Now, to be endothermic, this energy we see right here would have to be over here on the reactant side, okay? So if energy has to be put into a chemical reaction, it will actually be on the reactant side because you're having to put energy in to the reaction so that it will take place. And so this is, so if we did see energy on this side of the reaction, then it would indicate that this chemical reaction is endothermic, meaning that heat and energy has to go in for the reaction to take place. But in this case, this is not an endothermic chemical reaction. This is actually a exothermic reaction, and we can see that with the indication of energy being created. Now, a lot of times the chemical equation will not have this shown. Sometimes it does, sometimes it doesn't. The way that you can interpret it is let's say that this reacts, we would notice that the beaker gets hot because energy is being released. If we had energy needing to be added to the chemical reaction, the beaker would actually, or whatever the reaction vessel is, would feel cold because energy is leaving the environment and going into the chemical reaction. So here's another view of things that we talked about, a couple other things mentioned as well. I do want to mention that I did not have these right here, and that does not work because it covers it up. All right, these right here are what are known as the coefficients. All right, and we use these to balance chemical equations, which we'll do later in the year. These right here are the states of matter, okay? So we'll talk about these as well. If you see in parentheses a letter after a chemical or a substance, that is its physical state, solid. For this is a solid, this is gas, and this is a gas as well, all right? Now, and so once again, as opposed to the last slide, you can see that we've got two reactants but only one product. Sometimes you have two reactants and two products, sometimes one on one side, but multiples on the other. It just depends on the chemical reaction. But remember, this is your reactant, is what you begin with. They are what are doing the reacting. The product is on your right. It's what you produce. This is your yield arrow, which separates your reactants from your products, what you start with, separated from what you actually produce or form. If a catalyst is required, it will actually be written over the yield arrow, just like it was written over the yield arrow in our last slide. All right, this next slide is talking about substances, pure substances, which is basically all we talk about in chemistry for the most part. We talk about elements and compounds. These are the things that are on those periodic tables. There are the periodic tables that you guys colored and studied the last couple of days. These are your elements, okay? Elements form every single thing on this planet, living and non-living. It all starts here with the elements on the periodic table. So every atom has an identity that is one of the elements on the periodic table. These are just some of your examples. Now, when multiple atoms of different elements come together and combine, they form what are known as compounds. Now, compounds, the particles of compounds are referred to as molecules, okay? When you have individual elements, they're called atoms, but when you have individual compounds, they're called molecules. Now, what you need to know about, so these are both what are known as substances, sometimes referred to as pure substances, all right? To be a pure substance, all of the particles that make you up have to be identical. So see how each one of these are identical? And even over here, the particles here are identical, all right? These are more complex because they're made up of more than one atom, but they are still identical, okay? Each one of these has one purple sphere and then three green spheres attached to it, all right? So examples of compounds would be like sodium chloride or water, H2O, all right? But these are what are known as pure substances, and to be a pure substances, in order to be a pure substance, all the particles in a pure substance are identical, okay? So if we go over here and think about real-world products or different examples, over here you've got some copper wire. Every single atom in here looks exactly the same, just like we see here, all right? Over here we've got baking soda, all right? Baking soda, every single particle inside of baking soda looks exactly the same, except instead of being individual spheres of one element, they are more like this. They're a clumped group of atoms, but they're still identical to one another, all right? So it's like a compound is a group of chemically bonded atoms, okay? But these are both what we call pure substances, okay? All right, so the last thing that we're going to talk about in this slide is the idea of solutions. We already kind of touched on the solutions whenever we talked about the rate of dissolution, like stirring, heating, increasing surface area. But now we're really going to talk about the different components and parts. Now, you've got two images. You've got what we see at our level, like in the lab, and this is what's actually going on at the particle level, okay? Now, right here, the solute is what you are actually dissolving, okay? The solvent is what you're dissolving the solute in, okay? So this is, and together they create what is known as a solution. Now, this is not a chemical reaction. This is just a physical change. Still, what's inside of this is actually copper chloride. These are copper chloride crystals that have been dissolved in water, and you can see here's my solution. This is not a chemical change. It's just a mixture known as a solution, all right? Any type of mixture where the solute dissolves completely and evenly blends into the solvent, it is called a solution, all right? Now, at the particle level, we can see what's happening. You've got your solute, it combines with the solvent, and then what we see here, you can tell the differences between your copper chloride molecules or let's say your copper chloride particles and your water particles. But here, with the naked eye, with the unaided eye, we can't see all that. All we see is this fluidly blended solution. The last thing I wanted to share with you guys is the fact that this is not the only type. This is what we're accustomed to thinking. This sodium chloride, NaCl, is actually salt, table salt. So typically what we think of in terms of a solution is taking a solid and dissolving it in some sort of liquid to create some sort of solution, okay, that's also in liquid form. However, there's many types of solutions. You can see that gas mixing with gas, that's like oxygen gas and nitrogen gas and all the different gases that make up the air we breathe, carbon dioxide, that makes air. That's a solution. It's just gas mixed in gas. If you have carbonated water, a soda, that's gas that's mixed with a liquid, okay? So you can see that the solute in the solvent isn't always a solid and this always a liquid. It can be other forms of matter that are combined, and you can see here are your different examples for each one. So you can have a solid mixed with a solid, which makes your metal mixtures, your alloys. So that's all for your video lesson. I hope you guys took good notes. Be prepared tomorrow for your mini quiz. See you next time.